is a C++ vector? In C++, the standard vector stores elements in a contiguous memory, just like a C-style array. Well, why use the C++ vector? It has O of 1 random access time complexity, it is compatible with C APIs via the data method, and it's also efficient at resizing. To import the vector, we have to use #include vector. Creating a vector. If we type vector, arrow brackets, then the type. So for simplicity, I'm going to go with int. Now this will create an empty vector of size 0. Let's check that out. As you can see, 0. Now we create a vector with a predefined size like this. So the first argument in the constructor is the size. Let's check that out. Nice, we get 5. Now here, all of the elements in this vector will be 0 by default. To create a vector with default values, we have to add one more argument in the constructor. For example, here, a vector of characters will be of size 5 and will have only 8. Let's see if that's true. Nice. We can also use initializer lists by either passing them in the constructor or by using the equal sign. Well, this compiles. Nice. To copy a vector, pass a different vector as the constructor argument. Accessing items. The most basic way is to use the square brackets operator. In the square brackets, we have to pass the position of the element we want to use. So this should display 0. Okay, nice. Now I can modify an element in this index by using the equal sign. If I display this again, this should be 5 now. Nice. We can also use pointer arithmetic. First, let's use the data method that returns a pointer. Let's save it to a variable. Next, we have to add the position that we want to use to the pointer, for example 1. We'll display the first element, and then we have to dereference it. So that's 0, but if I access the element at the position 2, this should display 5. Nice. To display all elements, we can use a range-based for loop, just like this. For auto a in v1, let's see out the element separated by a comma. Let's see. Nice. And another way to access the elements is by using the .add method. So to do that, we have to use .add it instead of the square brackets. So for example, here I'm going to get the first element of this vector. Let's also add an end line here. Nice, it's 1. We can modify the element in a similar way like we did before with the square brackets. So for example, v4.add 0 equals 123.f, because that's a float. Let's display this again. Nice. Well, but what's the difference? The difference between the square brackets operator and the add method is that the .add method throws an exception. For example, if I try to access the 100th element, I'm going to get a runtime error. But if I use the .add method, I'm going to get an exception that I can catch. The add method throws an out of range exception. So const out of range. And let's display the exception message on the screen. Invalid vector subscript. Okay, nice. But if I did here square brackets, I get an error. Adding elements to the vector. To add an element at the end of our vector, we have to use the pushback method. This is going to insert an element at the last position. As we can see, 300 has been appended at the end. To insert an element at nth position, we have to use the insert method. For example, here I'm going to insert 100 at index 3. As you can see, value 100 is now at position 0, 1, 2, 3. Nice. Memory allocation. Well, a standard vector is a dynamic array, and it has to resize and copy each element if its capacity is exceeded. Here I'm going to print the size and the capacity. The size is the current amount of elements in our vector, which will be 6, and capacity tells us how much items we can add to the vector without it being copied to another block of memory. If I run this, both of those values are going to be 6. But if I add one value at the end and then print it again, the capacity has increased by 3, but the size only by 1. Let's see what will happen if the capacity is exceeded again. And let's display that on the screen. As you can see, the capacity is increased yet again. Now, the strategy of allocating memory here is different based on the compiler you are using. Okay, but now, for example, let's say we want to limit the capacity. So to do that, we can use shrink to fit. This method makes the capacity of the vector the same as the size. As you can see now, both are 11. To resize our vector, we can use the resize method, which is going to cut out all of the other elements. But as we can see, the capacity remains the same. Let's also print our vector on the screen. As you can see, the value at index 5 has been truncated. If we want to reserve a lot of memory, because we know that we are going to append a lot at the end of the vector, we can use the reserve method. It's going to change the capacity to this value. So now we can append 1000 integers to this vector without it copying the memory to another block. Deleting elements. To clear every element in our vector, we have to use the clear method. This will change the size to 0, and we will not have any elements left in our vector. So here, as we can see, nothing. If I print the size, we will also get nothing. I mean 0. Here we can see. Let's reassign the values to our vector. To remove the last element, we can use the popback method. If I print the vector again, you can see that the last value here will not be displayed. See, there were 3 ones, now there are only 2. To remove the nth element, we have to use the erase method. We have to pass an iterator, and we will start from the beginning, and then we have to add the index that we want to erase. So for example, let's erase index 4. So 0, 1, 2, 3, 4. Let's print this on the screen. As we can see, the 5 is not present in our array now. Remove elements from nth position to yet another position, we have to add one more argument to the erase method. For example, I would like to erase from the beginning, or maybe from the element at position 1 to element at position 3. Let's print the array again. As you can see, this removed only 2 elements, the 2 and the 3, because this is not included. So this method deletes all values from this to this, but not including the last one here. I would like to reassign our vector one more time. Now let's say I want to remove first item with a certain value. To do that, we can use erase together with the find function. For example, here, this is going to remove this element. Let's see if this works. As you can see, this removed the first one. So for example, we have 1, 2, 3, 4. This is going to remove every single one. I change it, for example, to 4. It will remove the item with value 4. Okay, so thank you for watching. Leave a like, comment or subscribe, and see you in the next episode. Goodbye.